All right, so today, refresher review number 2, unit 5. We're going to chat a little bit about rational expressions, simplifying them, multiplying them, dividing them, adding and subtracting, all that other good stuff. So, up here at the top, we're going to simplify each expression completely. Notice there's no equals, so I'm not solving something. Okay? No other formats, just trying to reduce. Factor when needed. Do not cancel binomial terms unless they're identical. In other words, when you see parentheses, you can't cancel stuff in there unless it's the exact same thing. You're like, well, what's this exact same thing mean? So as I'm looking through those, thank you. What we're basically saying is you have these bonds, these plus and minus bonds that are strong. So can I cancel these x squareds? No, at least not yet I can't. Because if I try, I'm going to mess everything else up. The only way I'd be able to do that is if there were no pluses or minuses there. So if I can't do that, what can I do? Well, I can factor things. So when I go back and I try to see how this would work, hopefully at this point, I've got some reminders for myself with this. And I go, okay, I got a difference of squares here. Because again, x squared, 49, both perfect squares. I square x to get x squared. I square 7 to get 49. And again, to get the negative 49, it'd be plus minus. And then I do that same concept down in the denominator. Except I just got to remind myself how the diamond works. And basically, I need two numbers that multiply to get the number on the end and add to get the number in the middle. Now, I get a couple of clues within that. And one of the clues is they multiply to a negative. Well, if they multiply to a negative, I know one's positive and one's negative because that's the only way I can get there. So it tells me that these two numbers are going to be 5 apart and that the bigger number is going to be the negative. So you're like, okay, two numbers that multiply to 14. They're 5 apart, bingo. Bigger one has to be negative. Okay. And I get those in there. Now I go back and look and say, okay, is there something that would be cancelable? And there is. Because I have two identical sets of parentheses right here. And what's left is my answer. Again, I'm not canceling the x's, they're bonded. If they're just loose, if it's just a multiplication bond, that's weak and I can cancel it. And speaking of that, that's what we're going to take a look at here on number 2. Now, if I see something identical right away that I want to cancel, I can. But otherwise, what I typically do is I just multiply straight across to get one fraction first, and then start working from there. So for instance here, if I multiply 25 and 4 and 5, okay, that's going to be 480. And then I add my exponents on my x's, because again, that's the rule with exponents and multiplication, is we add them. So 2 plus 5 is 7. Multiply my coefficients. And now it's down to one fraction, and I can go and try and reduce this. So typically, I'd go type in my calculator, 480 divided by 60. And I get 8, and you're like, well, how do you know that the 8 goes up top? Same way I do with any exponent rule. Wherever the larger value is, that's where my answer is going to go. And the same thing with my x's. 7 and 6. Now, I'm trying to remember my rules with exponents for dividing. We subtract them. So 7 minus 6 is 1. Bigger exponents up top, and I don't have anything down below left. I guess I could put a 1 there if I wanted to. But that's what this one would simplify to. And I'd be set. So again, nothing too complex. Okay, number 3, we've got some division. Reminder, you've got to flip the second fraction over. So not only am I going to have to factor stuff, but I'm also going to have to make sure that I do that when I get there. So same thing again. Multiplying to get a negative 5, so I know it's one of each. Adding to get 4, which tells me the positive number is going to be the bigger one. So 5 and 1. And then we're flipping these over. So in other words, this is what I'm going to have up top. So I'm going to deal with that first. Now, no difference of squares, anything fancy like that. What do they have in common, though? An x squared. Nice. So I take out the x squared. To get back to x to the third, I need one more x, because 2 and 1 is 3. And I just need the 2. And then I just factor that last one that's here. Now this time everything's pluses. That makes my life simple. So two numbers that multiply to 10 and add to 7. 5 and 2. And once I get that set, now I can go back and look for stuff to cancel. I can cancel within the same fraction if they're identical. I can cross cancel as long as one's in the numerator and one's in the denominator. I can't go straight across. Like if this x plus 5 would have been down here, wouldn't have been able to do anything. So I look to see what I've got left at this point. Because I'm like, okay, I got x squared. I got this x minus 1. And I got this x to the third down here. We can look at these and say, okay, I still can reduce that part. So 3 minus 2 is 1. Bigger exponent down below, so it's x, or you can put x to the first. And then I have this x minus 1, and again, don't be that person. Bonded, not bonded. Cannot cancel those x's. I'm done. Okay? Whenever you see plus or minus, putting the parentheses around is a good reminder that unless you see the identical thing, no canceling, no canceling, no canceling. Can't do it. So then we get to the part where there's a little more work. Adding and subtracting. Okay, first, you've got to find a common denominator and then work on building your fractions. And we'll talk about that in a minute. Once you've simplified your first step down to one fraction, then you can go back and look one last time to see if you can cancel or reduce something. But we don't cancel or reduce until the very end, because then we typically end up right back where we started, and that's kind of a waste of time for everybody. So I look at this first one, I say, hey, I already have a common denominator. I don't have to do anything fancy. So I'm not going to change the denominator. Once it's the same, I leave it alone. And now I just follow whatever it tells me up top, which is to add. So I'm going to combine like terms. 3x plus 4x is 7x. Negative 7 plus negative 3 is negative 10. I'm going to do my parentheses so I don't do anything silly, like try to reduce 10 over 5. Those aren't identical. Okay, well, that one was pretty easy and it's just done. I like that. Now the second one, I got to think a little bit. And we're going to talk a little bit about how to remember going through and finding my LCD. So when I'm looking for an LCD, nice, okay. I look to see first if there's any coefficients. Down here in the bottom, I don't see any numbers hanging out, so that's not going to be a big thing. Then I look for single variable terms, and Jessica just mentioned, we have one this time, x. And then we look to see if there's any sets of parentheses. And for every different one I see, that has to be included. So I have to do the x and the x plus 6. Okay, this x is different than that one because the other one's bonded. So that's going to be my LCD. And I'm going to keep what I already have, which is the 4 and the 2. But now my job is to go into fraction builder mode. So whatever I had to multiply this by to get to my new denominator, that's what I need to put up in the numerator. So I got the x plus 6. I just need the x. In the second one, I've got the x. I just need the x plus 6. And now my job is to get this down to one fraction. But now that I have a common denominator, I can do that. So I keep my denominator, 4x, and I got to distribute over here. So 4x plus 2x is 6x. 2 times 6 is 12. And then absolutely, we always want to look to see, can I reduce something? And I can take a 6 out of those. We'll see if that helps me. So 6 times x is 6x. 6 times what gets me to 12? 2. And I'm going to take one last look here. Parentheses aren't the same, so that doesn't help me. The 6 and the x, nothing reduces out there. I can't wipe these 6's out because this one's bonded, this one isn't. So that's as far as I'm going to get. And actually, in this case, even if you wrote the first answer down as your final answer, since nothing canceled, that'd be okay. But again, I got to build those fractions, and it starts with building my common denominator. Okay, I'm kind of working that through that way. So then as we keep rolling here, hey, ooh, this looks interesting. Okay, first with my denominator. If I ever see something that factors down there, I need to do that. And then I just kind of scribble out the old one. Because then what I'm going to do is I'm going to form my common denominator out of this. So I look, no coefficients sitting in front, because again, I'm only looking at the denominator. No x's hanging out that aren't bonded, so I don't have that part to do. X plus 3, x minus 3. But I need to factor to make sure that I get it that way. So I get here, now I just do the same thing that I did in number 5. I go, okay, old to new, so I got the x minus 3. I need the x plus 3. In the second one, I got everything. So if you want to put something down there, you could put a 1, but you really don't need that. And this one, I got enough stuff going on, I think I'm going to actually use one step to distribute here. If you're comfortable going straight and combining like terms and stuff, you can. So when I get to there, I'm going to distribute my 5 in the first fraction, so 5x plus 15. Then the trouble starts. This minus distributes to the 2x and to the minus 8. And if I forget about the minus 8, it's going to mess me up. So I got negative 2x, and then negative times negative is positive. That's why this one was a good idea to clean some stuff up. The denominator never changes. The numerator, 5x minus 2x is 3x. 15 plus 8 is 23. You see what happened there? The question out there was, I thought you were subtracting, but what I basically did was I took care of that when I distributed the negative through. It's the same idea that's working there. So either one would work. And we get that set. So then, okay, the one last thing we've got is some equations where we get into equals. So what we're going to do is we're going to multiply through by the least common multiple, but we could look at building it the same way we would a least common denominator, but it's not an actual denominator we're using this time, so we call it the least common multiple, which will eliminate the fraction part. Okay, then we solve what's left. That's how number 7 is going to work. So we'll do that first. So let me bump this up a little bit. So here, I've got to treat this the same way that I treated number 6 up above. If I can factor any of my denominators, I'll do that first. And then once I find what my LCM, or thinking it in the same way as my LCD would be, here, that's what I'm going to multiply through this entire equation by. Now that seems like that'd be a lot of work and take a lot of time, but it's actually going to go pretty quick. So let me show you how this works. So I write that on the outside. And I'm going to rewrite this in here. And could I have done it up here with this one? Yeah, I probably could have, to be perfectly honest. But I want to make sure we see everything, how this works. So I'm just going to recopy all the stuff that's there in the expression with my LCM on the outside. And basically, once I do that, I'm going to start distributing that value through. Now, here's how that works. I'm going to kind of cover up these other ones for a minute. When I go to multiply through, these things would also be up in the numerator. So when I look at that, I'm like, oh, well, the x minus 4s would cancel each other. So all that would be left is the x plus 4 and the 2x plus 1, because these guys would cancel. But I'm not literally going to cancel them because I need that for all three of these expressions that I have. So when I move to the next one, which is 3, you're like, well, wait a minute, nothing cancels there. So that would mean I've got x plus 4, x minus 4, because nothing went away that time, because there was nothing to cancel with that 1. And then finally, I get down to my last one, and I look, and the x plus 4 cancels, and the x minus 4 cancels, and all that's left is the 16 that was up in the numerator. So all my fractions have gone, there they go. So my job once I do that is to FOIL or box these out so I can start working this down some. So I'm going to do that part for you here in advance. And again, actually, let me move this up. I'm going to box this first one out just as a reminder, because I know it's been a while for some of you. So again, I kind of look at these that way, and I go, okay, I'm multiplying what's on the outer edges. So x times x is x squared. 2x times 4 is 8x. 1 times x is 1x. 1 times 4 is 4. And then I just combine my like terms together. So I end up with 2x squared plus 9x plus 4. When I get here, now if I think about this for a minute, I might be able to save myself a little bit of time, and here's what I mean. If I look at the x plus 4, x minus 4, remember where that came from. It came from this difference of squares. So basically what this is, and I'll write it up above here, is 3 times x squared minus 16. Because this is what that factored into. So if I remember that, then I just got to distribute my 3. Otherwise, if I boxed it back out, it's not a bad thing. I'm still going to get to the right answer. And I get that simplified out. And so the only thing here I have to keep track of now is if I see squareds, everything needs to go to the biggest squared side. So all this stuff on the left needs to get moved. Now, actually, I'm going to stop myself on that part for a second. Let me move that over first. I'm going to take a little extra space on this one, and I'm hoping you'll see why here in a second, because I got like terms over here. Okay, the 48 and the 16 are alike. They both don't have variables, so I can combine those. Now when I keep moving everything to the right, I run into a little different of an issue. I minus the 9x, you're like, but I don't have anywhere to put it. Well, I'm going to kind of put it in the middle here for right now. So we want everything to go away on one side, which we did. We still have a 0 there, though. That's right, minus 9x minus 36. And then the last thing now I have to do, you're like, wow, like there hasn't been enough to do already, is factor this so I actually get the answers, because there's an equals up above. I got to have answers. And again, on a final exam, on a question like this, there's going to be multiple layers, and so for the further you get, the more points you can get. It doesn't mean if you don't get to the perfect answer at the end, you're just wrong. It just means there's some little things that can go crazy here and there. So I will help out on this factoring deal. Because again, I knew it multiplied to a negative, so I knew it was 1 plus and 1 minus. I knew the bigger number would be minus, and that they'd be 9 apart. So I set those equal to 0. And before I circle, make sure that your answer doesn't cause a 0 in the denominator. Like, well, what do you mean? Okay, so I notice my answers are 12 and negative 3. So I look back to the original problem for a minute and say, if I stick 12 in there, does that cause this to be 0? No. If I stick 12 in there, does it cause it to be 0? No. Negative 3 minus 4, 0? No. Negative 3 squared, which is 9. Is 9 minus 16, 0? No. Okay, my answers are all good. But let's say one of my answers would have been 4. If one of my answers would have been 4, that's a problem, because 4 minus 4 is 0. So I do have to watch for that. But that's basically how that one would end up working out for me. Okay, last one on this review. And then the second one, if it's simply a proportion, just a fraction on each side with an equals in the middle. Okay. If that happens, we're just going to cross multiply and solve. Now, before I do that, remember, if I see pluses or minuses, I want parentheses, because otherwise I don't distribute in the right way. So I'm going to have 2 times x minus 1 equals 1x squared minus x. And I'm going to simplify it. I'm going to distribute. And just like we did on number 7, wherever the largest exponent is, the x squared, everything needs to move to that side of the equation. So I got x's that are alike. I got a 2 that's kind of off on its own here. So there's my 0, which I have to be able to solve. Be careful with your basic math, because I don't want you to do all this good work and then have something go bad here. But negative 1 minus 2, if I owe somebody $1 and I borrow 2 more, now I owe them 3. And I'll be able to factor whatever's left. Okay, let's see here. Multiplies to positive 2, adds to negative 3. Well, if this is positive, my signs have to be the same. Negative 2 and negative 1 gets me to negative 3, multiplies to 2. Set those guys equal to 0. But again, before you circle, take a moment. See if either of your numbers cause a problem. Okay, if I plug in 2, 2 squared is 4. 4 minus 2, that's not 0. 2 minus 1, that's not 0. Okay, that one's good. Okay, 1. 1 squared is 1 minus 1. Uh-oh. 1 minus 1 is 0. That's undefined. That doesn't work. So x equals 1 is not an answer. I only get one answer this time. Okay? So again, your job on the review for this one, we're skipping 1 through 4, because again, we did the graphing portions, bump that back to first semester this year. So basically, it's just going to be 5 through 24, that part in the end. If you need more scratch paper to work with, there's some up on the book stack up front. There is a key up front as well, so if you just want to see what the answers are to know if you're working towards the right thing, that's a good strategy too. And we will be tackling Unit 6, which is the trig stuff, in a little more depth